Hey everyone, we're back with section 5.2. We have already gone over some of this section in class, so whatever you need to skip over, you can. Whenever you need to stop it, feel free. I'm just going to scroll through these vocabulary terms because I do know that we have gone over them, but feel free to stop it at any point and jot anything down that you would like to. Remember, this section talks about medians and altitudes, and then the point of concurrency for both of those. So we're going to get started through the centroid, talking a little bit more about that and what it can do for us. Remember, the centroid is the point of concurrency of the medians that we talked about. And remember, the medians, think about kind of like on the highway, the medians is in the middle. So I always think of that median going from the vertex to the midpoint of that opposite side. Median, middle, however you want to remember it. So let's look at the centroid theorem. It says the medians of the triangle intersect at a point called the centroid. And remember, that's your point P right here. All of those midpoints that you can see with the tick marks on each side. Those are allowing us to say that J is a midpoint, K is the midpoint, and L is the midpoint. So all of those medians are intersecting at a point called the centroid, and that centroid has a special thing about it. It is 2/3 the distance from each vertex to the midpoint of the opposite side. So we wrote an equation down, putting those words into kind of a word type equation. Remember, we said the vertex to the centroid, so that segment, and an example of that may be BP, so we'll call that BP, is 2/3 the whole median. So BP equals 2/3, and the whole median there is BL. And that equation can be used when we're just talking about the whole median. We'll get to another type of equation similar to that one that we can use when we talk about the parts. So using that equation here, we have in our triangle that P is the centroid. Now, that centroid, a couple things you can remember, that we have midpoints on each side. So we know that V is the midpoint, W is the midpoint, and so is U. So that midpoint, those midpoints are there. I always like to think about the 2/3 rule. That helps me remember what I exactly need to do in these type of problems. They also give me that YV is 12. And notice that's the whole median right there. We are asked to find YP and PV. So if you look back up at that equation, right back up here, we are wanting to start off that equation from the vertex to the centroid. And if you can see that from the vertex right up here, so Y is the vertex where those two sides of the triangle come together, to the centroid. So I would call that YP, and notice that is actually what we're asked to find, equals 2/3 my entire length of that median. So I can say that the whole length is PV, or I guess, I'm sorry, YV, apologize. So YP equals 2/3, and they gave us YV, which is 12. So 2/3 of 12, YP is going to give us a value of 8. So I have 8 right there. Now there's two ways you can solve for that next segment we are asked to find, PV. One way is just to do the segment addition postulate, which is the part plus the part equals the whole. Well, if we know our whole segment is 12 and we just found half of our other segment, or part of our other segment, we can set it up as 12 equals 8 plus PV. And to solve for PV, we can subtract that 8, and we can get that PV equals 4. Another way you might think of this is when you think, oh, well, the top part is 2/3. So the bottom part must be 1/3 to make up that whole length. So really from our centroid to the midpoint, which in this case would be PV, equals 2/3 the whole median. So I would finish that off by saying, oh, I'm so sorry again. It is 1/3. We just talked about that. PV is 1/3 the whole segment, which is YV. So PV equals 1/3 of 12. And notice that I get the same answer there that I also did up top. So it's kind of whatever you see best. I'm going to have you stop this video right now, and I would like you to do the next checkpoint on the back page. And then I will show you the correct answer, and you can check it. Alright, welcome back to this video. Here is your correct answer. Hope you got the correct answer. We're going to move on to the next example number 2, and we are using the centroid theorem again. So they are giving us that CG equals 4, and we're asked to find GE. Now, we have to realize and notice what this picture is really telling us. Notice with all the tick marks, I can assume that D, E, and F are the midpoints. And the segments that connect with the midpoints actually go to the vertex, so I can now say that point G is my centroid. So I now know I can deal with the 2/3 rule. That's kind of triggering my brain to kind of think of how can I solve this problem. Well, we also know, we just talked about that CG is 2/3 the whole length, and GE is 1/3 the whole length. So I like to ask myself, how many 1/3s can go into 2/3? And I know that I can take 2 of CG and put them into, or 2 of GE and put them into CG. So I can actually write an equation that says CG equals 2 times GE. So this is when I'm dealing with the parts of my median. What would my equation say? And I like to put it into words. Again, my vertex to my centroid equals 2 times my centroid to my vertex, or to my midpoint. So those are the 2 or 3 equations that I think that we should really get out of this section. So to continue to solve this problem, they give us that CG is 4, so I'm going to take 4 equals 2 times GE. And to solve this problem, I'm just going to divide by 2, so GE will also equal 2. Looking back at this picture, if I erase all of the clutter, notice you should not come up with an answer for GE that is greater than what CG is. Notice that CG is the longer of the 2 sides, so that's a way you can check your answer. If you want to go ahead and pause this video again and do the next check your progress right below this, and then you can start it up and check your answer. All right, here is the answer in the work for your checkpoint number 2. And we're going to quickly move on to the next problem, our real world example. We're going to find the centroid in a coordinate plane. So an artist is designing a sculpture that balances a triangle on top of a pole. In the artist's design on the coordinate plane, the vertices are located at 1, 4, 3, 0, and 3, 8. What are the coordinates of the point where the artist should place the pole under the triangle so it is balanced? This is interesting. All right, we need to understand that we need to find the centroid of this triangle, because at this point, this might not be known, but at this point, the triangle is actually balanced, which I think is kind of cool. We need to graph our points that they have given us up above, and I actually labeled them, so if you want to go ahead and stop this video and graph these points. We need to use the midpoint theorem to find the midpoint of one of the sides of the triangle, because remember, the centroid is 2/3 the distance from the vertex to the midpoint. So how do we solve this? So we already graphed, so we already did that. We need to find the midpoint, and I just picked to find the midpoint of BC. You can actually do this to any one of the medians. So I'm going to find the midpoint. Remember, it is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So I'm going to do 3 plus 3 divided by 2, and 8 plus 0 divided by 2. I'm going to label this as point D. So my midpoint of my line is 3, 4. So I'm going to go over to 3, up to 4, and there is actually my midpoint. I'm going to call that midpoint D. So if you draw a straight line connecting those two from A to my midpoint, that actually creates a median. And we need to find the distance of the median, because if we find the distance, we can take 2/3 of that. So since it's a horizontal line, which we really, really like because we can just count that distance, we can see that AD actually equals 2 units. Now remember, the centroid is where it is balanced, so we need to find 2/3 that distance. So I'm going to take 2/3 times 2, and then I get 4/3, which also equals 1 1/3. So that number is actually telling me I need to start at A, and I need to go over 1 1/3. And that placement right there is actually where I put my point, which is my centroid. And remember, back up at the top, that is where I want my pole to go, because then it makes my triangle balance. So, but we need to find the coordinates of that. So we know we go over 1, 2, and 1/3 because of that 1 1/3. You can also think, okay, I started at 1 and I went over 1 1/3, so that would be 2 1/3. So 2 1/3, and then I'm going to go up 1, 2, 3, 4 to get the coordinates of my centroid to be 2 1/3, 4. All right, we are going to keep going, and we will probably cut this video into 2, but let's talk about our orthocenter really fast since we have a little bit of time. My orthocenter, just as a reminder, is the point of concurrency of our altitudes. And remember, the altitudes are from the vertex perpendicular to the opposite side. And depending on what type of triangle you have will depend on where that orthocenter actually lands. So we are going to stop this video now. If you are in regular geometry, you will stop after this example. If you are in honors, you need to keep going through example 4 of the next video. So I will see you in a second.